you very much, Mark. My name is Eva Sorensen, as Mark said. I'm the head of department for chemical engineering. I have a number of colleagues with me here today who will introduce themselves as we go along. I'll just tell you a little bit first about UCL and the department a bit more generally. UCL is the largest university in the UK at the moment. We have a number of different faculties in all kinds of different areas, of which we belong to engineering sciences. UCL, as you know, is consistently one of the top-ranked universities in the world. We're currently, in terms of global ranking, ranked 9th, and in the UK ranked 4th. In terms of research, in the last research excellence framework, we were ranked 2nd in the UK for research power and number 1 in London. Within the Faculty of Engineering Sciences, we have 10 different departments. We have the traditional engineering department, which you would expect, chemical engineering, civil engineering, electrical, and mechanical engineering. We also have departments within the faculty covering security and crime science, science technology, engineering and public policy. We also host the School of Management, which means that we have quite a broad range of work taking place. As one of the only departments in the UK who do chemical engineering, we have a separate biochemical engineering department within the faculty. As a department, we are ranked 5th in the UK. We are also ranked currently 19th in the world for chemical engineering. We have been around for a very long time. We were in fact founded over 100 years ago as the first department of chemical engineering. You can see some of the statistics here. You can see we have quite a large proportion of international students. Overall, this includes PhD students and master students, as well as undergraduate, and a large proportion of female students. Some of the programs that you will hear about today are based at our new campus at UCL East. It's a short trip away from our main campus at Bloomsbury. They will tell you a bit about the labs that we have, which is mainly housed on the top floors of this wonderful building. The building is 8 floors of high-tech cross-disciplinary research labs, which really means that those who do research there as part of their master's programs are really working at cutting-edge projects. The programs that we will be telling you about today, 2 of these are based at Bloomsbury on the main campus, Sustainable Chemical Process Engineering and Global Management of Natural Resources. And then we have the 3 new programs at UCL East, looking at Electrochemical, Propulsion Engineering, Digital Manufacturing of Advanced Materials, and Nature-Inspired Engineering. The first 2 programs here are accredited by their respective institutions. We are also looking at re-accreditation for which we have to do regularly for the Global Management of Natural Resources. We're also seeking accreditation for the new programs at UCL East. That cannot be done until the program has been running for a while, so we are in the process of doing that now. If you look at the student numbers in the bottom there, you will see that altogether we are a department of about, if we count everyone, about 1,000 people, so it's quite a large community. We do have an Athena Swan Gold Award, which is in recognition of our equality and diversity work. We were the first chemical engineering department in the UK to receive a gold award. In terms of research, it is obviously a core activity of the department, and it covers quite a broad range of scales, right from the molecular all the way up to a complex systems level, enterprise level. We have colleagues working within catalysis and reaction engineering, in electrochemical engineering, molecular and engineering thermodynamics, multi-phase systems, nature-inspired chemical engineering, and product and process systems engineering. So for the master's programs, the students will be working within one of these groups for their main project, but they will also be taking modules which are fitting in terms of one of these other areas. You can see some of our research highlights online. UCL's, the faculty has some disruptive thinkers videos where you could see how we could turn waste into more usable products when we are looking at a quest towards net zero. Where there's also a video that will tell you a bit more about what nature-inspired engineering is all about. We've also got some taster lectures on our YouTube channel where you can see more information about more specific examples. When we teach, we have all of our material available in our virtual learning environment. At UCL, we are using Moodle. So you can see a snapshot here of a module of what that could look like. We will typically be teaching a module about 3 to 4 hours, contact hours per week in 1 or 2 sessions. The modules vary a little bit in terms of how we teach. Some of them will be smaller group teaching, others will be slightly larger groups. We deliver the face-to-face teaching, but with a lot of online material supplemented to that, which we make available via Moodle. We have face-to-face sessions as lectures, as group work, discussions through guest lectures, practical activities, all the sort of usual teaching activities that you would expect. The assessment, if you look at the information per module, you will see how that is broken down. It is a mix of coursework, reports, projects, exams, group works and quizzes. Some of this is formative, which means it is so that you can test your knowledge, as well as summative, which means that it's counting towards your degree or towards your module marks. We are recording most of our teaching sessions. You will see one of our colleagues who's on the call today in active flow here being recorded. We do this for most of our sessions so that students are able to watch the recordings again in their own time. We put quite a lot of focus on making sure we have good content online. For some sessions, we're also making use of Zoom and Microsoft Teams where that is appropriate, in addition to Moodle and Panopto. The timetable is actually available online so that you could see what this would typically look like for a module. Here's a snapshot. You can see teaching sessions. This doesn't mean that all of these are active. The font is a little bit smaller here, but this will be broken down into different weeks and different terms. But this is one example of what it would look like. We normally try to keep Wednesday afternoons clear so that students have time to join societies, do sports and things like that. And that was all that I wanted to tell you in a bit more general terms. What we will do now is that each of the program directors will take turns to tell you about their specific program, and then there will be time, as Mark said, at the end for us to answer any questions that you might have. I'm afraid I will need to leave you now for another meeting, but you have all the experts here to help you with any questions. So thank you very much, and over to you, Izzy.
So I'm Izzy Mackay. I'm the program lead for our MSc in Global Management of Natural Resources, or GM&R, because that's quite a mouthful. Okay, so what do we mean when we're talking about natural resources? So we're talking about the provision of a whole range of natural resources, thinking about that are critical for the energy transition, for net zero, and for sustainable growth. So a natural resource expert facilitates the sustainable provision of the materials and resources we need, thinking about technical and socio-economic challenges we face in identifying, extracting, and supplying them. So we're thinking about the whole supply chain. So what do we deliver on our course? So we are, I think, It's an interesting course. We take a fusion of science and engineering with sustainable environmental and social practice. So we have a really strong ESG focus throughout, to give you that broad exposure to policy and practice across the natural resources sector. So this was developed in response to industry demands for skilled interdisciplinary workers. So interdisciplinary is really the key on this course, that you understand the challenges and any impacts, any decisions you make are. Because of the interdisciplinary nature, anyone with a demonstrable interest in the programme can study it. So we have students with science backgrounds, engineering backgrounds, earth science backgrounds, but also we've got marketing, business, economics, and anything in between, basically. So over the course, what do we aim to give you? So we aim to give you that broad technical overview of the natural resources sector, which might not be something you've particularly covered in depth before, including alternative and future uses of resources and infrastructure. So it's very forwards looking. We look at mining, including minerals, nuclear, hydrocarbons, energy, future fuels, and water, by understanding the science and engineering that underpins them, and then evaluating any economic, environmental, and societal management and governance factors that impact decision-making around these sectors. This gives you a critical knowledge base in the face of developing and disruptive technologies and the scale of the challenges ahead of us. And the picture on the right is a picture from one of our field trips to a mine site in Finland. So the course outcomes, we aim to give you that substantial overview of the natural resources sector. We aim to give you the confidence to contribute towards the decision-making process within associated industries. You'll lead and function effectively in multidisciplinary groups, hear from a range of experts from industry, hands-on experience with various aspects of the course, the ability to plan, manage, and deliver a successful research project, so that's a core part. Meet, work, and learn with a very diverse group of people, and live in another part of the world, crucially. So one of the unique aspects about this course is that we have a period of overseas study in Adelaide in South Australia between April and mid-September. And so I will give you an overview of what that means in a couple of slides. And as Eva has already mentioned, this is accredited with the IOM3 currently, and we are undergoing re-accreditation during 2026 for the next 5 years. So this just gives you an overview of the team on the MSc currently. So we've got a wide range of teaching staff, both based in here at UCL and also at Adelaide University, Craig and Albert at the bottom there. So this table gives you a little bit of an overview of the course structure. So we've got a combination of modules. We've got this underpinning in that science and engineering. So you can see we've got modules on oil and gas extraction, mining and mineral processing, renewable energy, geology, and then we've got some elective modules, including environment and resource economics, sustainability and decision making, water resource management, business and sustainability. We also have the option for a year in industry for a limited number of students, but that is not applied for at this stage. That would be once you're already on the course. We would talk to you more about that. You then do your dissertation in Australia in Time 3 alongside another module on social licensing tour in Australia. So in Australia, at Adelaide University, so this used to be University of South Australia, hence the picture. So UCL is a fantastic institution, of course, but being in London, it's much harder to connect with some of the challenges that exist on the ground, versus in Australia, there's a lot more connection with industry in the mining sector. So you would take your dissertation at Adelaide University, giving you that unique experience, and also some additional field trips to local industrial sites that we don't have in the UK. So this gives you a very quick example of a research project, the critical metals for clean energy transition, environmental implication of the transition. So you can see that there's a few different aspects within this that students might study for their dissertation, some more engineering and some more business focused. And then in terms of your industry links or employability, because we've got this interdisciplinary nature, the students go into a massive variety of different careers afterwards. So that could be consultancy, analysts, it could be engineers if you've got that engineering first degree, scientists, researchers, through PhDs. We've got lots of students who end up taking PhDs out in Australia as well. And at the bottom here, you can see a range of companies that we've got students, ex-students or alumni currently employed at. So I think that is it. So over to Adam Moeller now to talk about his MSc.
Right, thank you very much for that, Easy. So over now to the MSc in Sustainable Chemical Process Engineering. So why this course? In today's world, modern industries need to meet global needs. And in so doing, they also must conserve resources and reduce their impact on the environment. And we need engineers who are not only able to connect both their chemical and process engineering expertise, but they can also link that with sustainable innovation. So enter the chemical and process engineers who are able to design safe, efficient, sustainable processes and technologies that tackle problems like climate change, resource challenges, help improve our health, provide cheap, clean, and readily available energy, and also protect the environment. So what do we deliver on this course? So we will deliver advanced knowledge and practical skills in sustainable chemical process engineering through an Institution of Chemical Engineers or IChemE accredited course, which combines both top modules and a substantive research project, which is focused on real-world challenges. We also deliver expertise in process design, optimization, safety and sustainable energy systems with development of transferable skills, which will come in handy for your careers in global chemical or biochemical industries. We deliver a course which is open to a wide variety of graduates, including those who have a background in chemical engineering or related disciplines, including other engineering fields, chemistry, physics, and material science. So what do we aim to give you? We aim to help you develop advanced knowledge of chemical engineering principles and sustainable process design so that you are able to address complex industrial and environmental challenges. We aim to help you gain practical expertise through research projects and industry-relevant modules, combining technical depth with creativity and innovation in solving problems. You will also acquire transferable skills, which will be useful in terms of leadership, communication, and decision-making, which will prepare you for impactful careers in the energy industry, pharmaceuticals, water treatment, and other emerging technologies. So what do we expect that you will be able to do after you have completed this course with us? We expect that you would have mastered core chemical engineering principles and sustainable process design. You would know how to apply advanced mathematical and scientific methods to solve complex engineering problems. You will develop strong research capability through data analysis, experimentation, and critical evaluation. Practical skills in modeling and simulation you would also have gained, and also how to conduct risk assessment for industrial applications. Transferable competencies in terms of teamwork, leadership, and effective technical communication you would also have built. And if you are on the advanced chemical engineering route of this program, then you would have achieved an IChemE accredited qualification, which provides a direct education route to chartered engineer status. So here is a subset of the teaching and administrative team on this program. I say subset because literally almost every academic in the department helps deliver this program. And we also have academics from outside of the department that also support in the delivery of this module, of this program rather. What does the cost structure look like? There are two routes on this program. There is the advanced chemical engineering route and the research route. Both of them comprise 180 credits, which is made up of 60 credits, which is achieved on a substantive research project, and the balance 120 credits on 8 taught modules. The Advanced Chemical Engineering route, on behalf of the Engineering Council, is accredited by the Institution of Chemical Engineers, or IChemE, at Further Learning Standard, or F Standard. The research route is not accredited. And what does this mean? This simply means that if you have an IChemE accredited undergraduate degree in chemical engineering, and you do go on to complete the Advanced Chemical Engineering route with us here on this program at UCL, then you would have completed all the requirements for the education aspect of getting chartered. In other words, you then need to go further to get some bit of industry experience and demonstrate your commitment to continuing professional development for you to become chartered. The Advanced Chemical Engineering route includes 4 compulsory modules. That includes the research project and 3 taught modules. I'll talk about that in a moment. And then you have 5 optional modules to choose from. The research route includes 3 compulsory modules. That's the substantive research project and 2 taught modules. So you have 6 optional modules, making 1 additional one to the advanced route for you to customize the program to your career aspirations. The research route generally suits students without an IChemE accredited undergraduate degree. So on the right-hand side here gives you a breakdown of the structure of the program. Everything in red rectangles represent compulsory modules, which means it's compulsory across both routes, apart from the CEng 53, which is the process engineering and modeling and design, which is only compulsory for the advanced chemical engineering route. Everything in blue rectangles represent the depth modules, and the depth modules are the core chemical engineering modules, the traditional modules like your chemical reaction engineering, advanced separation processes, molecular thermodynamics. Everything in the purple rectangles represent the breadth modules. So these are the niche areas of chemical engineering like electrochemical engineering and power sources, sustainable water resource management, and so on. You also have the opportunity to take modules outside of chemical engineering, and these are in brown rectangles. For example, you have the entrepreneurship, theory, and practice. Like the GM&R program, there is also facility for students, a small number of students, to transfer to a second year on the program, which is the year in industry. So in the first year, you would have completed with us all the academic aspects of the program. And if you're successful in securing a placement with the company, then you will be able to move on to the second year where you will be able to put into practice some of the things which you have learned. In terms of facilities available to us, at the Bloomsbury campus, we have more than 1,200 square meters of research laboratory space. And there is also access to more than 2,000 square meters of research space at the UCL East campus, our Marshgate campus at UCL East. So here's just a few selection of equipment which are used in cutting-edge research. What sort of projects or research projects might you expect to do? So as Eva mentioned earlier on, our research projects are divided into 6 areas, and here's just a couple of examples. The first one is waste gasification for hydrogen production, which is in the area of catalysis and reaction engineering. And so this past project was done in collaboration with a waste gasification company where students were working with other engineers to develop a process for the production of low-cost biohydrogen for driving trains and buses. The second one there is life cycle assessment of plastic waste management, which falls in the remit of product and process systems engineering. And here students were collaborating with researchers at the UCL Plastic Waste Innovation Hub, where they were investigating environmental sustainability of plastics across the whole supply chain and conducting a life cycle analysis study. Where do our students go once they have completed this course with us? Our graduates are typically employed as process engineers, operations engineers, health and safety, executive and environmental supervisors, data and AI and analysts, fuel cell engineers. And here's just a selection of companies, which they go on to work for. And that ranges from places like Unilever to ENI Property, Royal Dutch Shell, and so on. So what are our recommendations for application? This program is open to strong undergraduate degrees, minimum 2-2, in chemical engineering or related disciplines such as chemistry, physics, material science, or other engineering fields. As part of your application, we would encourage you to put together a clear personal statement outlining your interest in the program, your reasons for studying or choosing UCL, your academic focus and career goals for the future. You should also mention, wherever possible, any relevant work experience or extracurricular activities that you might have participated in that could enhance your application. Finally, we would like one reference, preferably from a university lecturer, or if you've been out of formal academic training for a while, you might also want to get this reference from your employer. And in either case, they should be able to comment on your academic or professional strengths. So that brings me to the end of the MSc Sustainable Chemical Process Engineering. I will hand over to my colleague, Dr. Max Beisenhardt, for the MSc in Digital Manufacturing.
Hello, good morning. It's my pleasure speaking to you. So I'm the program director of the MSc in Digital Manufacturing of Advanced Materials. A long title, but I hope the next slides get an idea what we are teaching. So what is the MSc in Digital Manufacturing of Advanced Materials, or sometimes we just call it DMAM to be short? It is a study designed together with industry to address the new needs in R&D and manufacturing. As you know, AI is taking over the world, and we all have been affected. We all very much change how we do things, how we write things, but very much also how we develop things, how we develop and research materials, and how we manufacture things. So as the ways of R&D and manufacturing are changing, we have to develop new skills, and that is exactly what this MSc program was designed for. What do we mean by this? What do we deliver? Well, we do teach you AI and machine learning and these techniques. However, it's also very hands-on MSc program. So we do have these fantastic laboratory facilities. So this program is based at the new campus in Stratford, where we have the manufacturing futures labs and assigned teaching labs, where we actually have the robotics, the hardware, but also the electronic labs that allow you to get this hands-on experience on this technology that is bridging AI, machine learning, and these new digital technologies with the hardware that is made to be empowered by these technologies. And what we believe is that you are most likely to have a successful career, let it be in industry as well in academia, if you're not only experienced in computational skills, but if you're also experienced in the laboratory skills, in particular those skills that unite very well with the AI revolution. And the way I like to present it, so what you see is Tower Bridge, yeah? I'm not sure if you've been to London, very famous bridge. So what we provide through this program is we equip you with the digital tools. We equip you with fundamentals of data science, statistics, process simulations, machine learning, and AI. We do equip you with experimental tools. We teach material science, characterization, nanotechnology, flow chemistry, but we also teach the thing in between. We teach robotics, automation, high throughput experimentation, which is so crucial to actually bring AI to life. And that gives you these opportunities that this bridge that we're providing through this program is giving you. And let it be new drug molecule design, energy generation and storage, catalysts, sustainable processes, where all these technologies come together. These are the bridging technologies that we are teaching in this MSc program. Who are we? So myself, together with the colleagues you see here, this is the core teaching team. And as you can see, we're all very experienced in the field. We're all researchers ourselves as well. Most of us are also very industry experienced. So you will be taught by the team you're seeing here. which is a very reputable research and industry experienced team, but you will also be taught directly by many guest speakers from industry directly. So what are we teaching? Well, digital manufacturing with advanced materials, the name gives it away. It's a very interdisciplinary program. So in term one, and that is crucial, we start with the basics of the 3 disciplines. And the 3 disciplines are material science and high throughput experimentation. So that is more familiar to those with a chemistry, physics, material science background. But we also start teaching fundamentals of data science, which is less familiar to the disciplines I mentioned and might be more familiar to people from disciplines such as machine learning themselves, computer science, etc. So the crucial bit of term 1 is that we start to level the playing field. Whatever discipline you're from, we start with the very basics. In term 2, then, once you get the basics in term 1, we actually go in the lab and we start combining the coding experience you would have gotten by then, the experience in machine learning to actually control hardware. You will control the robots. So that is where we go in the labs. I have a few pictures as well to kind of get the program idea across. So this is the module I'm teaching, high throughput materials chemistry. Where we start teaching about fundamentals of matters, how atoms interact with each other, molecules on a very basic level. Yeah, we cannot go into details. It's a very broad overview, but that you are familiar with these concepts. And we end teaching about robots, flow chemistry, and how these things are digitally controlled. That is the one fundamentals of data science taught by my colleague Payman. That is where you will learn how to code. In particular, throughout this program, we are using Python. It is crucial. You do not have to know any Python before you start. You will learn this with us, and we also provide licenses to the Code Academy so that you can also, on your own time, get familiar with these technologies very soon. So again, you do not need to know Python. You just need to be motivated to learn these technologies. And after you're able to do Python, we use it for machine learning, AI, as I've mentioned quite a few times, and also more standard, if you wish, old-fashioned, but still very important fields of data science. This is all rounded up by my colleague Lauren, who you see here in this picture. She's teaching the module Applications of Digital Materials in Manufacturing, where you see how these 2 worlds come together. It's a very applied lecture, highlighting the many applications from material science, digital chemistry, and we also, as I've mentioned, have many guest lectures from industry. So this is one example of term 1 only. So we usually have a mix of small companies as well as large companies. So they give technical talks aligned with the field we're teaching. It obviously has to match the curriculum, but we also have a career session with them. And that's crucial. So you'll talk directly with industry, also about careers. You will learn from small startups to big companies, how to write CVs, how to approach them, because startups, big companies, they act very different, and you have the direct engagement to get career advice, and quite frankly, also start building in them. Term 2, as I've said, we go in the labs, you have these hands-on experience, and we're very lucky in the campus at Stratford that we have these fantastic facilities where you can learn the basics of electronics, but we have the robotic facilities as well. So these are the 2 big modules in term 2, where you start using this high-end equipment together with all the fundamentals you learned in term 1. In term 3, that is the one where you start doing research. This is where you team up with our excellent research academics. You have your entire term 3 that will be from April, May till end of August to do a really ambitious and interesting and hopefully also industry relevant research project with us directly. And that's also where you not only work in the fantastic teaching facilities, but directly with our academic groups in the research lab, such as the Manufacturing Futures Labs I mentioned just before. That is crucial now. Recommendations for applications. So who is this program made for? Well, to keep it short, it is made for everyone with a science or engineering background. To name a few disciplines: chemical engineering, biochemical engineering, computer science, electrical engineering, etc., etc., etc. The list goes on. What is the takeaway message? And that what I would like to read out to you is, if you have, as you see from this program, we are combining the computational skills with the material science skills, with the engineering skills. And there is no student that is experienced in all of them. And we do not look for students that are experienced in all of them. If these students would exist, we would recommend not to learn, not to do this program. They would have these skills already. If you feel like you have skills that match, but there is a lot you do not have, then this program is right for you. If you haven't been coding before and you want to learn how to code and use machine learning, this program is right for you. If you've done computer science, you're very good at coding and you want to know how robots work, you want to know how lab works, you want to know how these technologies empower R&D and manufacturing, then this program is absolutely right for you. So we are not looking for students who bring the whole package. We're looking for students who have some background in engineering and science and are willing to broaden to get truly interdisciplinary and get ready for their careers in industry or academia alike. So we're not looking for skilled students in all these fields, but we're looking for motivated students who are curious to learn more. That is from my side, and I will hand over now to Dr. James Robinson.
Thank you very much, Max. So I'm going to talk to you this morning about our MSc in Electrochemical Propulsion Engineering, and it's a program that's been renamed from our MSc in Advanced Propulsion, which you may have seen if you were looking at the course over the summer. Sorry about that. Really, we're entering an age of electrochemical propulsion. So that's propulsion of vehicles, be those cars, trucks, airplanes, or other aviation sectors, and all of those are being driven by batteries and fuel cells and the associated electric drivetrain with these technologies. We're seeing electric vehicles widely deployed across the world. In the UK, the uptake of electric vehicles is continuing to accelerate, and what we see with this is that as the technology enters the market, there are challenges that remain at all length scales of the system. So from the batteries and fuel cells, right the way through to the full powertrain, and those challenges are associated with lifetime, with the safety, with improving the energy density, and improving the cost of the entire system. And as the technology matures and EVs become ever more common, we're seeing people start to ask what's next. So thinking about electric vertical takeoff and landing vehicles, thinking about electric airplanes, and wider road, rail, marine, and aerospace challenges that could potentially be powered by batteries and fuel cells. And from our perspective, to solve these challenges, we really need a multidisciplinary skill set. So we need people with the background in chemistry, we need people with a background in engineering and in sort of electrical control as well. And we need to be able to bring these multidisciplinary skill sets together and work in an interdisciplinary way. So the course, the MSc in Electrochemical Propulsion Engineering aims to train you, the next generation of engineers and scientists, to allow the electrification of propulsion across a wide range of sectors, be it land, sea, or air. And in the course, you're going to gain great expertise and background and grounding in batteries, fuel cells, and electric machines. And most importantly, how you connect all these things together, because there's no point in developing one thing in isolation. It needs to work as part of a wider package. Ultimately, when you leave the course, we hope that you'll be able to tackle the challenges of net zero. And the course is designed for students who have a technical background, but particularly those who are interested in batteries and fuel cells, and more broadly, the kind of wider electric power systems. So the wider powertrain, electric motors, control theory, all of these sort of things are covered within the course. In terms of your background, we would expect someone with a background in an engineering discipline, in chemistry, material science, or in other relevant first degree. We've had students with environmental engineering, for instance, who've come in and done very, very well in the course. Ultimately, what we want is engaged students who want to work right at the forefront of electric propulsion, batteries, fuel cells, or electric machines, and students who really want to engage with some world-leading academics in this area who work alongside major industrial players in the field. Over the course of the program, you're going to get access to a lot of deep information with regards to batteries, fuel cells, and electric power systems. So we'll cover the fundamental principles. We don't expect people to come in knowing exactly how a battery works or knowing exactly how a fuel cell works. We'll cover that in the first term, and then we'll build on that, developing practical skills and research conducting your research project, which in general is highly industrially relevant and often informed by industrial research. You'll develop your design skills and you'll work in teams, developing those softer skills that are so important for your future career. And most importantly, as part of a research degree, you'll be taught how to engage with the current research in the area. We're seeing great steps being made continuously, so we really want to keep you up to date with what truly is state of the art in the research area. And that will all be framed in the kind of wider context of the ethical and environmental considerations of vehicle electrification. So this is just a snapshot of the team who'll be helping you out and teaching you over the course. So there's myself, sort of specialize in electrochemical systems. There's Alex Reddy and Alex Kibler, who work on electrochemical processes and materials. And then we have colleagues from mechanical engineering like Marlies Everett, Pedro Masef, and Peng Wu. So you get a really multidisciplinary teaching experience as well as a multidisciplinary learning experience in the course. The way we've structured the course is that you can either take a generalized route or you can choose one of 3 preset routes, and you do that in term 2 by the selection of your optional modules. And those routes are around materials, electrochemical power systems, or the wider systems and system integration route that we offer. To take those routes, what we ask students to do is to choose the associated module with those. So everyone will cover 5 core modules, those being advanced propulsion engineering, advanced characterization, your research skills, and then your design project, which spans 2 terms and is done as part of a team, and your research project common to all of our MSc programs, which is undertaken in term 3 and supervised by an academic here at UCL. But in term 2, you have the option to take 3 optional modules. If you take 2 modules from any given route, you can graduate with a classification in that route. So for instance, if you wanted to take the materials route, you would do electrochemical materials, structural materials, and one other optional module. I've shown the optional modules associated with electrochemical propulsion engineering here, but there are broader modules associated with sustainability, entrepreneurship, and whatnot that are available for students at UCL East as well. The electrochemical power systems route focuses on electrochemistry and pack engineering, and then the systems route focuses on electric machines and power systems, hybridizations, and drives. We genuinely have some amazing facilities at Marshgate, and these facilities are available to you throughout your research project. So as an example here, we have a battery manufacturing line where we can manufacture and test large scale batteries. We also have a 100 kilowatt dyno available if you're more interested in the kind of systems and power electronic side of things. And alongside these large scale design and test facilities, we have a wide range of characterization, testing, and for both systems and devices, and also safety within the building. And all of these facilities, as I said, are available to you and will support your research project, so you can do you can produce the best research project that you can as part of your course. Just to give you an example of some of the more recent research projects, we've had students looking at battery failure and the emissions associated with those. We've looked at new ways of estimating the state of charge of batteries using acoustics, looked at pulse charging in lithium-ion batteries, and looking at sort of the analysis of data acquired at a synchrotron for electrode manufacturing. We've also done things around X-ray computer tomography simulations and looking at electrolyte design for next generation batteries. But we're really open to working with students to co-develop a relevant project. So if that's something that you're interested in, please do come and talk to us at the start of the start of term 1, and we'll work with you and try and develop a project that's aligned to your interest. The curriculum of the program has been really inspired by what is genuinely long-term industry engagement, and that's with companies from small and medium enterprises through to very large original equipment manufacturers. And it's informed not only through conversations and through engagement, but through our wider research activities. So we have ongoing research programs with electrical vertical takeoff and landing vehicles. We lead some of the UK's research in next generation batteries, and we're heavily involved in battery safety and manufacturing programs as well. And from our first 2 cohorts, we've had graduates who've progressed into larger electrochemical engineering companies like Breathe and Fortescue Zero, system development companies like AVL, and have obviously gone on to do further study with PhDs. And we've students who've undertaken their PhD in the UK, in Canada, in China, and beyond. And that's it from me. So I'd just like to hand you over to Dr. Diego Lopez Barrero. Thank you very much.
Okay, hello everyone. My name is Diego, and I am the program director of the MSc in Nature Inspired Engineering. So, as you have already heard in previous presentations today, there are new approaches that are urgently needed in the chemical industry, in the manufacturing industry, so that we can prove its efficiency, its circularity, the waste that they produce, so we can reduce the waste that we produce or develop in general more adaptive and sustainable systems. And this is where nature excels. So nature has been great at developing scalable architectures and hierarchical networks to more efficiently transport nutrients or exchange gas and liquids. It has also developed optimized transport mechanisms. It has also developed ways of collectively organizing dynamic systems from seemingly disordered building blocks. And also it's way more robust, adaptable, and modular than our current industrial practice. So that tells us that we can learn a lot from nature, and this is precisely what you would be doing in this program. So you would learn how to harness these principles from nature and apply them to design the scalable, efficient, and adaptable technologies and processes. This is a globally unique approach that we have pioneered here at the Chemical Engineering Department at UCL, thanks to the existence of the Center for Nature-Inspired Engineering for over a decade now. And in this slide, I just would like to show you a by no means comprehensive list of some of the technologies that have come out of the Center for Nature-Inspired Engineering. We have developed, for instance, gas distribution systems for fuel cells that have been inspired by the fractal structure, the branching structure that you see in lungs, anti-fouling filtration membranes that are inspired by the coatings or the outer side of our cell membranes. We have also looked at nature to develop better cancer treatments, more homogeneously distributed fluidized bed reactors, or more efficient catalysts. So this is just a very quick overview of the kind of fields that we can impact by taking inspiration from nature. So if you decide to join us, this is precisely what you would be learning during this 1-year postgraduate course. The teaching that we deliver in this course is very related to both the research that we do here at the Center for Nature-Inspired Engineering, but also in many other renowned institutions worldwide that also work on nature-inspired engineering. And after spending a year with us, you should be able to tackle complex manufacturing challenges in a wide range of fields, as I showed in the slide before. So areas like materials engineering, process intensification, renewable energy, environmental technologies, biomedicine. These are all fields you should be able to in which you should be able to tackle manufacturing challenges after having studied with us for a year. And in general, this program will give you a unique competitive edge that is increasingly demanded in R&D, in entrepreneurship, and in industry. So we see more and more demand from the job market for engineers and scientists with a multidisciplinary profile that are able to talk the language of different disciplines. And this is precisely what you would be doing in our program, just by virtue of being in a multidisciplinary cohort, being exposed to a wide range of fields. So who is this course for? Well, we basically welcome applications from all engineering and science backgrounds. So you have seen before the kind of fields in which we can apply these nature-inspired approaches. And that reflects also on the kind of students that we welcome. And we also welcome applications from those with recent industrial experience. But more importantly, what we're looking for is for students who wish to work at the forefront of this industrial transition towards more efficient, more sustainable, and more resilient processes and products, and that want to learn that by working alongside leading academics and, that also have collaborations with major industrial partners. So at the end of the program, you should be able to implement fundamental principles from nature and use them to solve complex engineering and design problems. You should also be able to recognize in which situations these nature-inspired technologies will bring up a new and better performing solution. And besides technical skills, you will also acquire a wide range of soft skills. One that is very important is this interdisciplinarity that I mentioned before, because we see an increased demand of these skills in the job market, but also other soft skills like scientific presentation, technical writing, project planning, management, and delivery. And you will do all of this by meeting, working, and learning with a diverse group of people in London, which is one of the most vibrant cities in the world. The teaching team that we have assembled to deliver this program reflects also this aim for multidisciplinarity that we have. So we have people with industrial experience, with academic experience that have worked in fields like bioengineering, membrane technology, process intensification, reactor design, catalysis, renewable energy. So all these sectors are covered by the expertise of our teaching team, and it reflects also this aim for multidisciplinarity that we have in the program. The way the course is structured is shown in this slide. So there are a few compulsory modules throughout term 1 and term 2, where you will learn fundamentals about nature-inspired engineering, and then also more applied aspects like materials engineering, a design project, or also more related to how to deal with dynamic systems. You will also have 2 compulsory modules that run throughout the entire year. And those modules are related to research skills and quantitative research methods. And then you will have 2 optional modules that you can choose, one on each term. We have a list of optional modules offered by our department, and those are shown in bold in this at the bottom of the slide. But there are also a wide range of UCL list modules, and you can see all of them in the prospectus webpage. And those courses are related to things like sustainability, entrepreneurship, and you will also be able to choose from those. And then on term 3, you will go to the lab and you will carry out your research project. This research project is an individual research project that you will carry out under the supervision of a member of our academic staff. And the aim of this project is for you to develop and enhance your abilities in guiding a project and delivering results on a project. The project takes place during the summer in the Manufacturing Futures Lab, and the topics that we normally offer are selected from the research areas in which the staff members of our department are currently active. But as James also said before, we try to adapt those projects to cater as much as we can your interests. So if you have an idea of the kind of project you would like to develop during your studies, please come talk to us at the beginning of the year and we can discuss that. And I think this is my last slide. So in terms of recommendations for applications, if you think that you have the right profile or you fit with the description of the student or the candidates that I showed a few slides before, then I would definitely encourage you to apply. And when you do so, please demonstrate in your application why you have an enthusiasm for the topic of nature-inspired engineering, and highlight any key personal experience that showcase this interest or that also have supported you in the decision of pursuing this MSc. We will also need, as for the other programs, an academic reference or a reference from somebody that has supervised you in the industry and that can showcase your capabilities. And I think that's all. We are looking forward to welcoming your applications. And I think we are now at the end of the presentation. So we have a few minutes for some questions and answers. But before that, we have here a list of slides, a list of links or emails that you can use to contact us, depending on which program you're interested in. So any questions that you have, please use our general email address or contact the program directors of each specific program. And then do follow us also on social media. We have regular posts about the application process, the season, the future events and things like that. So I think we can start then with the Q&A session. So I'll be reading some of the questions that you have been posting during the session. So the first one is a general one that applies to all the programs. So this is a question about somebody with a BS, so a Bachelor of Science in Petrochemical Engineering, that is from outside of the UK and would like to further their studies at UCL, but they have questions about the funding. So they would like to know what funding opportunities are available, and then the admissions requirements, and also if working and studying is an option for these programs. So in terms of funding opportunities, I would refer you to the prospectus of the program you might be interested in. If you go to the end of the prospectus, there is a section about fees and funding. You will be able to see the cost of the program there, and there are also some links to bursaries and scholarships. So please take a look at that and see if you can find something that is suitable for you. In terms of admissions requirements, then this depends on the program, but that's also listed in the prospectus. So if you go to the web page that has information of the program you're interested in, you should be able to find the answer to your question. And then work and study options are available. I think unfortunately not. So if you go to, again, the prospectus, you will see a section at the very beginning where it says study mode. And I believe that all of our programs say full-time. But if not, please somebody correct me. But I do believe, at least for the program that I'm program director of, we don't allow a study and work option. So it's a full-time study program. You would be here on a student visa if you are from outside of the UK, and that visa would only allow you to study. Okay, so that was a general question that applies to all the programs. And then I think we can take a look at some other questions in the chat. So let me scroll through the chat. So there was a question for GMNR. So easy. So the question asks about the finance and visa requirements for going to Adelaide. So if you could answer the question.
So in terms of the visa requirements, Adelaide or Australia are fairly open. Everyone, like, you will have to apply for a visa, but most countries, nationalities are eligible for a visa. But the cost of that and the cost of traveling are all to be covered directly by the student. We do have a couple of scholarships available to support, some small scholarships available to support that. But again, as Diego said, a lot of the information around financing is on the prospectus, and we have broken down the costs associated with traveling to Australia there.
Okay, thanks, Izzy. So there is another question that is for the Nature and Spartan Engineering program, and says so the question is, do you welcome applications from candidates with a biotechnology background? Yeah, the answer to that question is yes. So as long as you have a STEM background, that can be engineering, that can be chemistry, physics, then you're more than welcome to apply to the program. We're as I said, striving for or aiming for a multidisciplinary cohort. So as long as you have a STEM background, you're more than welcome to apply. There is a question also for SCP, so Ademola. So the question is, looking at the program prospectus, I seem better suited to the research route, but I would like to become chartered in the future. Is this possible? And does choosing the research route limit me?
Yeah, so thank you for that, Diego. Yes, it is possible for you to get chartered even though you're on the research route. All it would mean is a slightly longer process to get there. But there is what is called the individual case procedure, which has been put in place now, where the IChemE actually assesses your undergraduate degree and compares it to the standard UK undergraduate degree. Once you're able to scale through that process, then you get onto the route of being able to get chartered. So it is possible. It's only going to be slightly longer. Thank you.
Okay, thanks, Ademola. There is another question also for your program that says, so do any of the modules on the SCPE program require prerequisite knowledge, and how can I find what these pre-requirements are?
Yeah, so some of them do require prerequisite knowledge, and there is the UCL module catalog where you can type in the code of the module. So if you do go onto our website, we've got all the modules listed there. And if you click on any of the hyperlinked modules, it takes you straight to the UCL module catalog, and you can see the ones that have got prerequisites. But we also have quite a number of them that have no requirements for background knowledge. So a mix of them in that sense.
Okay, thank you, Ademola. Let me scroll through the chat. So there is a question for Max. So Max, you mentioned in the program that it was co-developed with industry. How is this reflected in the MSc?
That is reflected in the learning outcomes, that is reflected in the material we're teaching, and is reflected by them actually teaching with us. So especially in term one, we have several industrial guest lectures, as I mentioned. So they're not only presenting what they're doing, they're presenting what they're doing in relation to the program. Just to add to this, how this was developed, we have an industrial advisory board at UCL Chemeng, and we obviously run this program by them, and they gave a feedback throughout the progress, throughout the development, what is needed, what is in demand. And the one advice I would give to everyone on this call is have a look at the job ads that are out. Have a look what skills are needed, because the best way I would feel to decide what MSc to go for in general your career is have now a look what job ads are out there, what skills are they requiring, and what skills do you not have at the moment, and you could make up with the right MSc for you.
Okay, thank you, Max. Thank you, everyone. I think we are slightly over time now, so if it's okay, I'm gonna finish the session now. But yeah, as we showed before in the last slide, you have all our contact details there. So if you have any questions about the program, about the application process, about funding opportunities, please do not hesitate to get in touch with us, and we will be very happy to help you with your application. So I think that's all for now. So thanks everyone for joining, and yeah, looking forward to welcoming your applications.
Bye.
Bye.